Next, we'll study about the 2 is to 1 multiplexer in detail. Okay, as its name suggests, whenever they ask you to do this multiplexer, you have to draw the block diagram like 2 is to 1 marks. Like it's so easy marks that you that this won't be come in your paper, but to understand the basic knowledge of marks, you should know this one also. Okay, and output is denoted by y, input is denoted by D naught and D1. When there is more pin, that pin is known as enable pin. And can you tell me how many there would be the select line in this case? By the formula 2 raised power m is equal to n. So in this we are having two inputs, right? That would be one select line that would be represented by S naught. Now the question is, what is enable pin? Like suppose you are having your house, right? And in your house you have seen MCB, right? You have seen na MCB. So if MCB is off, then would and your room switch is on. Okay, this is your room and your switch is on for the fan, suppose. So if your MCB is off, your switch is on. Will fan will work? Yes or no? I'm again asking if your MCB is off. Okay, but you entered into the room and you switch on the fan. So will fan work or not? No. Now the another case, if MCB is on and you switch on the fan, then your fan will work or not? Then in that case will work. So now the thing is, if MCB is off, then we'll get no output, right? This is the same thing that have been done by enable pin. If enable pin is 0, whether we will give input or not, the output would always be equal to 0, right? If the enable pin is 1, or 0 always represented off and 1 always represented on. So if the enable pin is on, then only in that case we'll get the output. And this enable pin will be in each and every case of multiplex. Got it? So now we have to draw the truth table for the select line also. In the select truth table, we are having three input. One is the enable pin, another one is the select line, another one is the output that is represented by y. Okay. If enable pin is 0, select line can be anything. It can be 1, it can be 0. If the thing is 1 it can be 1 or 0, that is represented by cross. Okay, so output would be always, tell me, if the enable pin is 0, then output would be what? 0 or 1? Enable is like your MCB. So if the enable is off, then output 0 or 1? Tell me, right? Now I own the enable pin. Now the enable pin is 1 and select line is 0. Okay. Now this select line is 0. Then the output be D note always. And if the enable pin is 1, a select line is 1, output would be the second output, second input, that is D1. Remember I told you the example for the t-shirt jeans, right? What I told you, if I select 0, then what output will get, what is in the first box, right? If I'll select 1, then what output will get in the second box, correct? Now the same thing applies here. If I select here 0, then it like there is a switch in this, then output is connected with the D note, okay, like this. So D note would be the output. But if I select 1 over there, then in that case what happens, that output is connected with the second switch, that is that I show. So if select line is 0, D note is selected. If select line is 1, D1 is selected. So if there is only one select line, there is only two possible combination, right? Either it can be 0 or it can be 1. Got it? Any doubt up to here? Now we have to we have to make an expression from the truth table. What was the expression? That is y would equal to E for enable, right? I'm doing for these two. For enable, if select line is 0, then we'll mark it as S bar. If select line is 1, then we'll mark it as simple S1. Okay? And the output is what? B naught. Plus, now we'll draw it. Now we'll write the expression for the second case. Now, can you tell me the expression for the second case? For enable pin, it's 1. So, we'll write down E. Select line is also 1. So, we'll write down S. Output is D1. So, we'll write down D. Got it? Okay. So, now we got an expression. This one, that is y is equal to S bar naught plus S1. Yes, D. Now we have to make a logic gate expression related to this. So how many are the inputs? We are having four input E, S and one D node, right? So we can mark it here E, we can mark it here S. So E and S bar is also there. Can I draw a NOT gate over here? That would be S bar. E I have taken and S bar, sorry, that's S bar. So I have taken E and S bar and denote also. So I put a small denote input like this. That would be how much? E S bar denote. Correct? Now the next term is E, then S, and then D1. I can mark like this, right? That would be D1. That would be E, S, D1, right? Then we have to put it with the OR gate because these two expressions are combined with the OR gate. Now the OR gate is like this. Then we'll get the final output, right? Okay, tell me if there is any doubt up to here.